Welcome to part 4 of Competency 19. In this video, we will discuss word problems relating to leisure and entertainment using our TI-84. Okay, use the following for numbers 1 and 2. Okay, the Dallas Cowboys Jumbotron at the AT&T Stadium in Arlington, Texas, has an angle theta equal to 24.23 created by the diagonal R. And they give us a diagram, basic diagram of the Jumbotron. Okay, so for number 1, it says, which of the following equations represents the area A of the Jumbotron? Okay, the fact that they're giving us a diagonal labeled as R and they're giving us an angle tells me that we need to look at polar coordinates, which says trig. Cries out trig identities. Okay, and I know that we need base times height to get, we're going to need it in polar coordinates to get just an area, okay? So our base, that would be our x. Okay, if we said this was like at the origin and we're looking at it, drawing it out, this x, our base, or actually we could call that b for base, which makes more sense. So our base would equal r cosine theta, okay? And our h, or our height, would equal r sine theta, okay? Right, when we're taught this, we're taught that the base would be x and the height would be y, like on a coordinate system, and that's how you deal with coordinates, polar coordinates rather. Okay, so if you don't remember those things, please go look online. There's lots of great videos. There's actually printouts. Refresh your stuff on the basic trig identities. Okay, so we need base times height. Well, our base is r cosine. And I'm going to go ahead and put in our value, okay, of our theta, 24.23. Okay, now I'm going to multiply it times our height. But we have r again. All of it's multiplied together, so I can say r squared, okay? And then I just write down the sine theta. But our theta, again, is 24.23. Okay, and we are doing area, so base times height. Okay. However, let's look at what we got here. We have an r squared, so let's look at our options. Well, D does not have an r squared, so I'm going to get rid of that. That doesn't look quite right. Okay, A has an r squared, but it has more going on. Okay. B has an r squared. Ooh, but the r is actually replaced with our theta value, so that can't be right. Right. Okay, so this narrows us down. Narrows us down to two options. Okay. Now, I'm looking at that sine value that looks suspicious. So this is what I'm going to do. We got two separate things going on. We have to deal with what's going on with our r squared. But let's also look at what's going on with cosine theta times sine theta. Okay. In our trig identities, something comes to mind. Okay. That would be a double angle. Okay, and when I'm looking over here at the sine squared, that doesn't say double angle in my mind. That it would be the cosine. If you're talking about double angle, that would be cosine 2 theta. Those are different identities. They don't relate to sine times cosine. But if you've done enough trig, you do know that sine 2 theta, double angle, 2 times your angle is going to equal 2 cosine theta sine theta. Okay. Now, if we replace that and if we take and use this and we say 2 times our theta, well, let's just do that. I know you could probably do it in your head, but it's not worth making a mistake. Okay, we get that. Okay, that's a check mark. That's a plus. Okay, but we don't need this 2 right here. Well, look at what happens with A. They divide by 2. Okay, so if we divide by 2, if we're dividing this whole thing by 2, that would get us the correct answer. And we're about to find that out in number 2. And of course, I've looked ahead on this. So I see divide by 4 right here, and I see squaring here. It just doesn't fit with our needs. So let's go with A. Okay, that makes sense. But if we go to number 2, that's actually going to verify our suspicions because it says if the diagonal length R equals 175.45 feet, what is the area in feet of the Dallas Cowboys Jumbotron? Okay, now that makes sense. What they're saying is, hey, if you go and substitute your value of R in the equation that you have, you should get the correct value. So let's go try to do that. Okay, 175.45. Let's square it, but they're saying divide it by 2. I'm going to divide it by 2 right now. Okay, and then we're going to multiply it by the sine theta and cosine theta. Okay, times sine 24.23. Okay, then I'm going to say cosine. Notice that I did not have to press multiplication in between that. And let's push enter. Sine, cos. Oh my gosh, I did it wrong. Oh my goodness, I did sine and cosine instead of just, oh, that won't be the same thing at all. Not a problem. Make a mistake like that. Go back up, capture where you knew you were correct. So we take the 175.45 squared. I'm going to grab that. Now I'm going to do it correctly. I'm going to say sine 2 times. Okay, let's make sure I do it correctly this time. 2 times what? Notice that I'm not multiplying it in my head. Okay, it should be 2 times theta. All right, 24.23. All right, that way I know I'm matching that I am correct. And I have a taker, and I know that that is correct. Number 3, the Alamo Dome in San Antonio, Texas has a capacity that varies depending on the event and the type of event as follows. So they've got all of the occupancies, capacities, all listed according to the fire marshal. Okay. And it says if the Spurs play a basketball game on Thursday, I'm going to stop right there. If you look at basketball, and we are talking about the Spurs, look at how many people that fits compared to football and soccer. Now you know why the Spurs don't play there anymore. Anyway, I'm going to continue. Okay, if the Spurs play a basketball game on Thursday, so we go ahead and put Thursday up there at maximum capacity. Okay, so this is their capacity. All right, so I'm going to circle that. So that's what we did first. Okay. Then on Friday, what happens? And a soccer club plays a game at 89% capacity on Friday. Okay, I'm doing this because writing the T and the F for Thursday and Friday, because put it in your mind where we're going. We're starting at the lower number for basketball. And 89%, let's figure that out real quick. 0.89 times the 64,000 capacity. That's how many people fit in the building. See, that increases, okay? That's going to be the 56960, and this goes here. So we're going up, okay? Just want to make that point. Let's get to the actual question. What is the percent difference in capacity from Thursday to Friday? Okay. I have created a little graphic for us to help us out with this. We'll go up. Okay. So we know that I wrote it right there, that here, okay, we have 31,900 people that we can fit in. But right here, okay, remember we're going to start at 0 and go up this way. It's basically a little number graph. Pretend like all the numbers are filled in, like a number line, just to help us out visually. Okay, then we're going to go from there up to 56,960. That's a lot more people. But the question says, what is the percent difference in capacity from Thursday to Friday at the Alamo Dome? So this was Thursday. Remember, I already pointed that out. And this was Friday. And the difference is, let's go with it. We need a bit different. Okay, different color. Well, that didn't help. Okay, let's see if it'll give me the right color. There it goes. Okay. The difference in those are, let's put it in the calculator. 56960 minus 31900. Okay. Yep. So we have a difference of 25,060. Yeah. Big reason why the Spurs aren't going to play there. They found another location and looking for another one. Okay. So because there's such a great gap there, and it is increasing, but how do we decide this percentage increase? And if you look over at your answer choices, you can already see that I'm looking at an increase and that our ABCD is trying to kind of trick us. And this looks like we would be choosing, I don't know, we may not even be choosing this, but it's not decreasing, it's increasing. So I would go ahead and get rid of those. Could be wrong, but I don't think we're going to end up with either of those numbers. Okay, but what are we doing? We need the part over the total. But what is our part? That's how you rationalize these. So you have part over total. So obviously our part is our difference because they asked for percent difference. So don't grab the wrong part, which would be the 31,900, and then divide it by our capacity for Friday. That's not, or even go up and grab your 64 thousand that you started with. That would be an understandable, but I could see somebody doing that rather, but not a good choice. So we need our difference over our total. So this is our total, and of course that's our difference right here. Okay, let's put it in the calculator and see what happens. 24, 25,060 dividing by 56960. Okay. And if you don't feel comfortable with the decimals, to get your percent, just times 100. You can move the decimal if you want to. So I'm going to round that to 44%. Why would I know I have to round that? We're talking about capacity, meaning people walking in the building. You round up for people. Remember, never round down for people. You cannot put half a person on a bus. You cannot take off half a person. Well, Strictly speaking, that's just, let's not even get into that. I remember my seventh graders lived discussing that, but no. Anyway, that's our answer. A, 44% increase. Number 4, according to a particular recruiting website, the top 10 highest paid Texas cities for golf industry jobs are listed in the table to the right. Okay, there's all our cities of Texas. There's our salaries. Which of the following graphs is the best representation of the data and displays the measures of central tendency appropriately? Okay, measures of central tendency tells me a lot. Okay. All right. Now, here's our graphs. Let's take a look at those real quick. Oh, we need to clean up a bit of mess there. Okay. Not a big deal. Okay. So we have box plots, or years ago they called whiskers. They have decided to change the name recently, but whatever. Doesn't matter to us. Looks like we have different shaped box plots. And if you don't remember all of the parts of a box plot, uh, stop the video, go take a quick look. Your Q1, your Q2. I'll take you through it though quickly though. Okay, now let's go back. And first thing I'm going to do is count how many we have. And let's write it in. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oh, looking at all these cities, I think I've been to every single city there. Oh, and I live right by that. Imagine that. Anyway, moving on. Okay, so that being said, here's our salaries. What do? We need to put these into the TI-84. It is a list, so that means we are going to push stat, and it's highlighted on what we need, number 1, because we're going to edit our lists. We have all our nice lists. Now, I've put in the first 8 for you. We need to put in 9 and 10. And then I already had L3 numbered 1 to 10 from another thing I did, another question I answered, and I just cleared out 2 so we could see it. No need to do much more, okay? Except we do need to arrow down and enter in our last items. Now we do need to double check. Number 1 was Austin. Austin's correct. Then the second one, yes. Number 3, Cibolo. Cibelo's correct. 4, okay, 2, 3. Yes, all correct. Okay. It's better to double check before you move on. So 39919. And okay, that's for orange. And then Temple 39134. Enter there. Okay, make sure you enter after the last one. And then if we have 1 to 10, it's level with 10, so we know we have them all in. Okay, now what do we need to do? First thing, back out. We need to go to stat and see where it says calc. That means we're calculating the measures of central tendency. They told us what to do. We need mean, median, or we need mean. We're not going to be we're not going to be doing mean. We're going to be doing median, and we're going to be doing Q1, Q2, Q3, low and the high. Okay. Right. That means that we're going to do number 1. That means one variable var stats, one variable stats, one column. Okay. All right. So then we're going to push 1. L1 is where I put my data, so I need that. Okay. I'm leaving the frequency list empty. We're not dealing with that in this problem. Okay. And all the information I need and much more is here. If they ask me a different question, I would be ready with a median and other things. One important thing is when you're doing a question like this, look at your N. Notice I numbered these from 1 to 10. I did that for a reason, so we could know that we had 10 items. So we know we at least put in enough. Okay, so go down. Here, there's our Q1 for our box plot. And our Q2 is our MED, our median. Okay, there's the value. There's our Q3. And notice our minimum is in there. That's our low. And there's our max. That's our high. Okay, so let's take a look. Let's take a look at A. For A, the minimum's correct, the maximum's correct, but our Q2, which would be right here, this line right here, is your Q2. That is incorrect. Okay? So we know A is not right. So let's go to B. They don't give us a minimum or, look at what they did. See that value? That's our Q1. Okay. And look at our Q2 and our Q3. That's the same Q2. That's wrong. So we're not keeping that. Let's analyze our Q3. Q3 is actually this high. And the low's wrong too. Our Q1 is not the. So basically what they did is they put all the numbers here and an incorrect for Q2 to see if you would, if you understood the box plot I exposed. So I guess we're left with C because there isn't a D. So what this tells me is we need to check. Okay, we need to verify somehow. And I have an idea. The first thing to verify is CRQ2 underneath this 40,000. It's not right on our Q2. It's a little bit less. Well, look, that makes sense because our Q2 is 40,026. So that's just a little bit more. So that checks. Our Q2 checks. But we don't have a way to measure this, but we do have something. Okay, I'm going to say it's C, but let's prove it to ourselves. Let's back out of this. Let me show you what to do. Let's make this plot. So we backed out. Let's go second y equals. And what y equals does is it gets me to the box plots. Okay, our box plot is on. We want to do number 1. And it's on, but it's not on the right kind of plot. So go over and then go down and then arrow over until the second to the last. That's the right kind of box plot that we want, okay? And then let's go, okay, wait a second. We had our information in L1. However, we need our Y to be L3. You know what? Let me see if I can clear that and it'll work. I don't think it will. Let's back out, go to Zoom. And I did have L3 in there. Remember we had our 1 to 10 in L3? Usually it asks you for that. But let me see. I've never tried it without it. Oh, yeah. See what it did? That didn't work. It didn't save what we wanted. Let's put it back on. Let's go back over. And second to last, enter it. Oh, it put it in L2. That would be the mistake. So let's see if we can clear it. Let's see if it'll do it with just L1, okay? No guarantees, but let's try it. Let's back out. Out of curiosity, I want to go back and see what happens. Nope, back on L2. We're going to have to put L3 in there. Did you see what I did? I pushed second and number 3, and that'll get it. But I now have too many of them. Second, yeah, there we go. Enter it. Wow, that's what I should have done. Okay, so that'll work. Let's back out, go back to Zoom. Number 9 is our Zoom stat. That always gets what we want. So push number 9. And what it did is it pushed it up to the 10. But at least we know that C is the correct shape. Compare the shape of what we have in our calculator to C compared to A and B. Definitely what we want. So we know C is our correct value. Number 5. In the diagram of a target shown to the right, each of the concentric rings numbered 10, 20, 30, or 40 has a radius of 1 inch larger than the next smaller ring. The bullseye, worth 50 points, has a 1 inch radius. Marissa is a skilled dart player. What is the probability that her dart will land on the 30 ring? Okay, bear with me for this one. We will not use the calculator for this one. You could. There really isn't a point. Let's keep everything in terms of pi, okay? And let's talk about this radius, right? So they say the yellow, which would be the bullseye, is going to be a 1. And no, this picture really isn't to scale, so it's 1. And all of them going out larger. This is one more, then this is one more, then get white, then this one's one more, then this one's one more. I know I picked blue. Okay, so what does this mean? This means we're going to take and do some subtracting. We're going to get areas of circles and subtract. So the largest circle is 1, 2, 3, 4, 5, has a radius of 5. So the area of the large circle equals, well, pi is r squared. So that would be 5 squared. So that is going to equal 25 pi. Okay. Now, the next thing, we're dealing with a 30 ring, so where the number 30 is, okay? So we're going to take that one. What we need to do is take that whole circle, okay, all the way, the whole radius of 1, 2, 3. We're going to take it, and then we're going to subtract. We're going to call that the color circle, the whole colors. We're going to take all the size of the color circle. We're going to subtract the area of the yellow and red, okay? And then that whole thing we subtract from the larger one. It is confusing, but you kind of have to think it out, okay? So what are we going to do here? So let's see. I'm going to put a line right here so we know that we have our large circle, okay? So then we're going to take the entire 1, 2, 3 radius circle, okay? So the area, we're going to call that the medium-sized circle. Okay, so that's 3 pi. Okay, so pi r, oops, 3 r, 3 for the r there. Okay, 3 squared. So that is going to be 3 times 3 is 9, 9 pi. But now we still have to subtract out this smaller one to get the size of that uh, 30 ring. I'm sorry. It took me a second to think of what to say. Okay, so that is going to be the smaller yellow and red, okay? And that will be 1, 2. So our radius is 2. So that's r squared. So what is really happening here? Okay, we're going to put just an implies. We are subtracting. Oh, I did it again. Ah, good. That should be a 2. 2 times 2 is 4. So we are going to subtract 4 pi from the 9 pi. That gives me 5 pi. So we took the medium, okay, which was this whole color ring. The medium circle is the blue, the red, and the yellow all together. Then we subtract out just the red and the yellow. That leaves me the blue. So that blue is this 5. Now, what do we need to do at this point? Here, let me get my color back. Okay, so what do we need? We need the part over the total. Okay, well, what is the part? What is the total? The total is the whole circle. Okay, and that is what? We've already said that 25 pi. Okay, but what's the part that we're interested in? Well, just the 30 ring. Well, that's 5 pi. Now we can just do some basic canceling. Cancel out the pi and well, 25 is 5 times 5. Mark one of those out. We have a 5 left. Mark that out. So what do we really have? 1 over 5. Okay, but we need a percentage. So what do? 1 divided by 5.2 times the 100. Oh no, I divided. Well, clear that out. Point 0.5 times, I mean, point 0.2 times 100. And that gives me 20%. I have an option. That'll be C. Okay. Not a lot of calculator needed. You could have done that all in the calculator, but if you keep things in terms of pi, it makes life a lot easier in that situation, not in all situations. Okay. A coordinate grid is placed over a baseball diamond so that home plate is at the origin and first base lies on the positive x-axis. Let one unit in the coordinate plane represent 1 foot. That makes sense. The right fielder catches the baseball at the point 206. That will be your X, and your Y at 20. They have it marked. How far does the right fielder have to throw the ball to get a runner out at second base? Round to the nearest foot. Okay. So here is, okay, we've got our right fielder. And okay, looking at this triangle that they drew, that is not a right triangle. But to get the distance that we need, it's straight. There's our second base. Okay. Now that's not showing up very well. Let's use this. That didn't. Goodness, that doesn't show up either. That doesn't help me. See if this one will write. It'll write over here, but it won't write on here. Oh, there it goes. Okay. All right. So we have that. Do we have enough information? First off, I'm going to ignore their triangle. That's misleading. But notice that they said right here, first base is on the axis, and they have it marked here in with the blue dot, and that's at a distance of 100 feet on the axis. So we can go straight up and we can say, I can go ahead and erase that now. We've proven our point. Okay, we can say that, trying to get this thing to work, that we're at 100 at second base. And then if we go over, we see that that's halfway. So we can say that that's 90. Okay, and we are rounding, so we know we're estimating. Okay, and then to continue, okay, so we're going from the right fielder where he's standing right here. Okay, we can, along the grid at 20, now we've drawn a right triangle. Okay, using the information in the diagram they've given us. And what is our distance? Now, wait a second. If second base is 90 feet away from first base, but our right triangle is 20 feet above that. So this means we have a distance of 70 feet from first base, or not, actually, we're not even going from first base, from 20 feet. Okay, so that would be our 70. And then from the 100 feet to the 260 feet, well, obviously that's 160 feet. Well, that's a nice right triangle all dimensioned out for us. We can calculate how far he has to throw that just by using the Pythagorean theorem. Okay, so I'm going to say second square root 70 squared plus then the 160 and squared push equal. And that is, I would say, rounding up about, and it says round to the nearest foot, so that has to be 175 feet. So that's C. Okay. And thank you so much for watching. If you haven't subscribed, please do. We have more videos coming, even other things planned. But could you please consider giving us a like? Please share us and subscribe. Thank you very much.